Good evening. Good evening. Am I audible?
Yes, sir.
Okay, only you have joined now. Maybe I will wait for a couple of students. Okay, so maybe we can start. Yeah, I'll be discussing quantum mechanics 2 actually, MPH-008. So we have already discussed in the early part of the course about symmetry and time translation, space translation, and rotation. So translational symmetry, rotational symmetry, and uh, basically our time translation. So today we'll be talking. about parity. Parity. So what does actually parity does? Parity is a transformation, basically a space transformation. So takes the point x, y, z under parity transformation. It goes to minus x, minus y, minus z. Okay. So what happens to a wave function? So it is actually unitary, special unitary operator. So if I'll say, let's say, psi prime is the new state generated by operator psi, where this is basically our parity operator. Okay. So then, if I try to find out the expectation value, let's say, so psi prime x psi prime, this will be just equal to minus of psi x psi, and similarly psi prime y psi prime expectation will be equal to minus of psi y psi. Just a second. All right. So what does this does actually? It changes the expectation value from positive to negative, or it basically reverses from a positive right-handed coordinate system to a negative one. So in general, if we'll try to write using, let's say, psi prime x psi prime x psi prime. Now, this I can write this psi prime. In order to write this, see, psi prime I have already written is equal to pi psi. So, if I take, for example, psi prime pi, this is just be equal to uh, psi prime, sorry, just a second, one second. Yeah, psi prime. This I can write is equal to uh, pi psi, pi psi. This is basically equal to psi pi dagger, pi dagger. Okay. So if I try to use that over here, so then what I will get is psi prime x psi prime expectation is equal to psi pi dagger x pi psi. Now this must be equal to minus of psi x psi, right? That's what we have already defined. It will go from x, y, z to minus x minus y minus z, or basically x will go to minus x, y will go to minus y, and so forth. So this implies pi dagger x pi will be equal to minus x cap. Hmm. So if uh, I multiply, if I multiply a pi onto the left, so that will be like pi dagger x pi will be equal to minus pi x. Now pi dagger must be equal to, since they are unitary. So that's why that will be equal to identity x pi must be equal to minus pi x, or x pi plus pi x is equal to 0. Okay. So this is actually written as anti-commutator uh, bracket. So that is basically equal to x pi anti-commutator is equal to 0. So similarly, we can write y pi anti-commutator is equal to 0, z pi anti-commutator is equal to 0. So position operators anti-commute with parity operator. Position operators with parity operator. Okay. Now, if we try to operate, or we try to see the action of parity operator on position eigencase. Next, what we will be interested is action of parity operator on action of parity operator operating on position eigencase. Position eigencase like x, y, and z like this. So what will happen? Let us see x pi operating on x cap. This is from anti-commutator. We can write this is equal to pi x with a negative sign operating on x. All right, pi x operating on x. So what is pi x or pi operating on x? What is it? Pi operating on x, or maybe I should write it like this. Uh, that would be better. Like x pi operating on x must be equal to minus pi x operating on. This is basically coming from anti-commutator algebra. Now what is on the left hand side? Left hand side will be equal to x. Pi operating on x will give me minus x. X will go to minus x is equal to what? Is equal to what? Pi minus pi. X operating on x. What is it? X operating on, what will it give? The position only, right? It will only give me the position, isn't it? Simply x times. All of you are following? ବୁଝିହଉଛି ନା ନାହିଁ? Yes? Am I audible?
Yes, sir.
Okay. So because I'm not getting any response from your side, I thought it is somehow disconnected. Okay. So if we write it, if we write it like this, so what we can write now is basically uh, from this calculation we can directly write uh, pi cap operating on x is basically minus x. So or if I double operate, if I double operate pi operating on pi x will be equal to pi operating on minus x will be equal to x. So identity. So this implies pi pi is equal to identity. So pi square is equal to identity. Okay. So parity operator is such an operator, is a unitary operator. So pi dagger pi will be equal to identity, but at the same time, pi square will also be equal to identity. Pi square will also be equal to identity. Okay. So if we go to just a second. Uh, yeah. We will come to this part, the block one, uh, chapter two, parity operator, page number 40. I suggest all of you go through this page number 40 and 41. And if you have any doubt, you can ask. Otherwise, I'll move over to the next transformation operator using parity. ସମସ୍ତେ ଟିକେ ଏଇ ଦିଟା page 40 and 41 parity operator definitions and properties ଟିକେ ପଢିଦିଅ. Take 5 minutes and then we'll move over to next part. Okay. ବୁଝିହଉଛି ପ୍ୟାରିଟି ବିଷୟରେ ନା କିଛି ଡାଉଟ୍ ଅଛି? Okay, if no more questions, then maybe I'll move over to the next part. So, what we understand is if parity operates on state, then it goes to minus x. Isn't it? Or basically, what parity does is it takes from xyz to minus x. minus y minus z position. So what happens to momentum? What happens to momentum? Momentum is what? In classical picture, P is equal to M dr by dt, right? Since your R is basically going to minus R. So if you take dr by dt, it will go to minus dr by dt, right? The transformation is this is transformation. This is not transformation. So M dr by dt will simply be transformed to minus M dr by dt. Or basically P will move to minus P, parity transformation, isn't it? Now what happens to the momentum generator? What happens to momentum generator under parity? Under parity. What will happen? What is the typical momentum generator? If you can recall, T cap epsilon x is equal to identity minus I epsilon x px by h cross by h cross. So similarly, if you can write for y direction, it will be I minus I epsilon y py by h cross and t cap epsilon z. Right. Now, what will happen if I operate parity? Or if I parity means let me move it a small distance. Huh? So if mm, let me come to the picture in the if you come over here, so translation followed by space inversion. So first is translation. Body was at x0. Okay, body was at x0. It moved to x0 plus epsilon x. That is the translation. And then you operate parity. Then you operate parity, and it will take to minus of that, right? But if you first, let's say this is like first in this A part, it is first translation, second parity. Okay. In this case, first parity, second translation. First parity, it was at x0. So first parity means it will invert to minus x0. Okay. And we want to, if we want to go to the same point P prime, that means we have to, from minus x0, we have to take another minus epsilon x. Then only we'll move over here. Okay, from here to here, we have to go in a negative x-axis, epsilon x. Okay, so that means if we first So T epsilon x and pi will be equal to pi T of minus epsilon x. Is this part clear from this picture? This relation. এটা বুঝে হচ্ছে T epsilon x ର କାମ କଣ? It will basically move the system by epsilon x. It will transform the system or translate the system by epsilon x, right? Yes, any question? No? Okay. Let's then do the mathematics. So what we get from this picture understanding is that T T epsilon x pi must be equal to pi T of minus epsilon x. Okay. Now if you substitute, so what is T epsilon x? I'm writing again T epsilon x, which is I minus I epsilon x px by h cross. And what will be T minus epsilon x? I plus I epsilon x px by h cross. So if we substitute, if we have this relation A and this relation B, if we substitute these two over here, what we will get? We will get pi, oh sorry, I minus I epsilon x px by h cross. This with pi must be equal to pi I plus I epsilon x px by h cross. Okay. I pi I basically same, so that will cancel, isn't it? I pi I will cancel. So this implies this will be equal to minus I epsilon x px by h cross pi is equal to I pi epsilon x px. See, this px is the operator, I is the operator, but epsilon x is not the operator, divided by h cross. So h cross will cancel, I will cancel, but of course pi is an operator. So what will remain? Epsilon x px pi with a negative sign is equal to epsilon x pi. Since this epsilon x is a number, it can go to the left of pi. So pi px. So I can cancel epsilon x on both from both sides. So what I will get? Pi or px pi plus pi px is equal to 0. This implies my px pi anti-commutator is equal to 0. So similarly, py pi anti-commutator is equal to 0 and pz pi anti-commutator will also be equal to 0. Got it? Since pi is an unitary operator, pi is an unitary operator. Since just a second. Pi is a unitary operator. Huh? So what I can do? So I have from this relation px pi plus pi px is equal to 0. I will multiply pi dagger. I'll multiply pi dagger onto the left. So pi dagger px pi plus pi px will be equal to pi dagger into 0, which will be 0. Okay. Now, what exactly I'm getting? So pi dagger px pi plus pi dagger pi px is equal to 0. This implies pi dagger px pi. Now this is basically identity. So this will be equal to minus px. Minus px. Okay. So similarly we can show pi dagger py pi is equal to minus py. The pi dagger pz pi equal to minus pz. So if we compare it with position operators, so comparing with corresponding position operators, we can simply write pi px will be equal to minus px z. All right. Now, what will happen to the momentum in a parity operated eigenstate? What will happen to the momentum operator in parity operated eigenstate? That is psi, just a second, psi prime composite. So what we will write basically psi prime px psi prime like this. Now whatever we have equal, whatever we have done for position, we'll do similar mathematics. So this will be equal to psi pi dagger px pi psi like this. This is equal to psi pi dagger px pi psi. But from here we know pi dagger, sorry, here, pi dagger px pi is basically minus px. So here I can substitute. This is equal to psi minus px psi. Right? So this is simply can be taken outside psi px psi. So, or basically psi prime px psi prime. Okay, clear? बुझे उसका? Am I audible?
So,
Okay. So then I suggest all of you uh, again go for this part of the mathematics. Uh, this transformation operators, page number 42 and 43. uh, just quickly go through it. If you can understand it or not, then I'll move over to the angular momentum part. Take 5 minutes, go through this text, transformation operator, page number 42 and part of 43. If there any question, ask me. Else, I will move over to momentum operator. Okay, 5 minutes. Huh? Hmm. ବୁଝିହଉଛି?
ସେଠି ବୁଝିପାରୁନି ସାର୍।
କୋଉଠି
ମଝିରେ
ବୁଝିହଉନି?
ମଝିରେ ବାର ମଝିରେ ଯୋଉଟା ଲେଖା, ଦିଟା ବାର ମଝିରେ ଯୋଉଟା ଲେଖା ହଉଛି ସେଟା କେମିତି ପଢାଯିବ? ସାଇ ଷ୍ଟାର ବାର ଏକ୍ସ କ୍ୟାପ ବାର ସାଇ।
କୋଉଟା କହିଲ କୋଉ?
41 ପେଜ ର ଏକ୍ସପେକ୍ଟେସନ ଭ୍ୟାଲୁ ଯୋଉଟା।
କୋଉ ଜାଗାରେ ଲେଖା ହେଇଛି ସେଟା?
ସାର୍ ପେଜ ର ଯୋଉଟା ଟ୍ରାନ୍ସଲେସନ ର ପୂର୍ବ ପେଜ ଟା
ହଁ।
ସବା ଉପରେ ସାର୍ ଫାର୍ଷ୍ଟ ଲାଇନ ଟା ଯୋଉଟା ଲେଖା ହେଇଛି ସବା ଉପର ଫାର୍ଷ୍ଟ ଲାଇନ ଟା 2.3।
Okay, on my screen, this line, right?
Yes sir.
This line here. So that is psi star. Sorry, psi prime x psi. That is basically expectation value, right? This is psi prime x psi prime. This is expectation value, right?
Expectation value means
Expectation value means it's basically if you go to your wave mechanics, so that is like psi star x psi dqx integration, right? This is what you have done in BSc, isn't it?
yes sir.
Yeah. So that is in bracket notation. In bracket notation,
Yes sir.
I had discussed it actually in the previous two classes in the beginning. Actually, I had discussed this. Maybe you have you were not there, but this is what you can correlate psi star x psi dqx, whatever it was there in wave mechanics. So that is in bracket notation is written like this. Okay.
Yes sir.
Yes. So go through it. Go through it because these are very fundamental. So once you understand this, other things will be easier to understand. Okay. Just
Yes
go
sir.
through it and let me know if you have any question or doubt. Then I can clear it. Okay.
Okay sir.
Yeah. Yeah.
Sir, by tiger means
Dagger means see all operators can be uh, represented in terms of matrices. Okay, all operators can be represented in terms of
matrix.
matrices. So the complex transpose is basically the dagger operator. Okay, so for example, I can simply say any operator A. Sorry, any operator A can be represented in the form of a matrix. Okay.
Okay.
So a dagger means I will take the transpose and take the complex of each of them. Okay. You know transpose, right? Rows into columns, columns into rows. And
Then
then I will take the complex conjugate of each element. जो element ଟା ଥିବ ତାର complex conjugate ଟା ନେବି.
a plus I b a minus I b a plus I b ଥିଲେ a minus I b ହବ।
Yes, yes. So complex conjugate of each element and then make a transpose. So that is basically your A dagger. Okay. ଟିକେ ରିଭାଇଜ କରିଦବ ଯୋଉଗୁଡା ବିଏସସି ରେ ବି ପଢା ହେଇଥିଲା କ୍ୱାଣ୍ଟମ ମେକାନିକ୍ସ 1 ରେ ବି କୁହା ହେଇଥିବ ଗୌରୀ ସାର୍ କହିଥିବେ ହେଲା ଯୋଉଟା ବେସିକାଲି ଡ୍ୟାଗର ଅପରେଟର କଣ ୟୁନିଟାରୀ ଅପରେଟର କଣ ହେଲା
ସାର୍ ଗୌରୀ ସାର୍ ପୁରା ରିଡିଂ ମାରି ଦଉଛନ୍ତି।
ମାନେ basically you have to go through the text. Okay.
Yes, sir.
Yeah.
Sir,
Okay. You
evening,
you go through you go through these two pages and let me know if you have any questions on that. I'll clear it. Okay. Specific questions on it. I'll clear it. I'm say page number 43 ର up to this point you ପଢ 3.2.13 ସେଠି ଭିତରେ କିଛି ଯଦି doubt ଅଛି any point you can ask. I'll clear it.
पूर्ण एकदम पूर्ण
Yes, ବୁଝି ହଉଛି ନା କୋଉଠି ଡାଉଟ୍ ପାରୁଛି?
ସାର୍ ସାର୍ ଦେଖିକି ଟାଇମ୍ ଟିକେ ଲାଗିବ।
Okay. So then I suggest you go through this text today, and I'll continue from this angular momentum in the next class, because only you are in the left in the class. So you go through it. Maybe you can ask me in the next class. Okay.
ఓకే సార్.
Yeah. So then that will be okay.
నమస్తే.
Okay.